Hey there, students. I'm going to graph some rational functions for you just so you can get some practice tomorrow. All right, so on all of these, we're going to look at the mid behavior. And we're going to look at the end behavior. We're going to use this analysis to build our table of values, and then we'll graph it. Mid behavior. And end behavior. So end behavior is only whether it's a horizontal asymptote or an oblique asymptote or something else. So in this case, the numerator's degree is lower, so we know that we have a horizontal asymptote at y is 0. Okay. So in the question, I'll lead you through it. I'll be like, part A, this is the horizontal asymptote. So you've got your end behavior there. And then everything else is mid behavior. So to get that, we need to really factor this thing. But that's easy to do here. Okay. So what kinds of things are we interested in the mid behavior? We're interested in zeros. We want the y-intercept. We want vertical asymptotes. And then holes. Those are really kind of the only things that are possible for mid behavior of rational functions. So the zeros are when the numerator is 0, and notice no factor cancels there, so we're not getting a 0 over 0, so there are no holes. So this thing is a real factor, and it's causing the thing to go to 0 at -3. The y-int is when x is 0. And then if x is 0, all we're left with is the two constant terms, so it's the ratio of them is -3/4. So that would be -0.75. Vertical asymptotes are when the denominator is 0, so that happens when, so these two lines are our vertical asymptotes, and then there are no holes. So that's the analysis. That's what you do. So now you set your table of values up. You try to be smart about it. You know that the vertical asymptotes kind of show you where everything is happening. They're like the center of it, kind of. So I'm gonna put them in here, kind of in the middle. And then our y-int is directly in between them. These were vertical asymptotes. And it would be probably a good idea to get some middle behavior between them. And then we had a 0 at -3. So let's put one over there too. And then that's it. So let's try to go beyond it a little bit. I think we'll be able to see it. I'll just go a little bit past. That should do for what we need to do. So we'll use our calculator to do this. So we'll put the numerator first, divided by x squared minus 1. X squared minus 4. Sorry. Alright, let's play this. So now we'll go to our table. And we'll just go down this list. -5, -4, 3, 2, 1, 0, 1, 2. Yeah, I'm just going in order. Okay, so I'm getting -0.09, it rounds to -0.1 basically. At -4 I'm getting -0.08. 3 was 0, like we were expecting. Then vertical asymptote. -1, I'm getting -2/3. At 1, I'm getting -1 1/3. 3, I get 1.2, then 0.58, and then 0.38. Alright, so that's kind of a weird table, but hey. Keep in mind that near your vertical asymptotes, if I were to get closer, they would go vertical, so I do need to go. I find my highest and my lowest value in here. Well, let's set the x-axis up first. Probably just do -8 to 8. That's probably good. Now to set this up, the smallest number in here was -1.33, and the biggest one was 1.2. So I'll probably just go for. I want to go past those, so I'm going to go -4 to 4. That'll look really nice in the calculator anyway, because the grid is 2 to 3. Alright, that should work pretty good. So let's start plotting. -5, -0.1. That's very close to the x-axis. -4, -0.8. Is that really what it was? It was 0.08. Right? Yeah. So it's even closer to the x-axis there, but not much. And then at 3 we had a 0. And then at -2 we had a vertical asymptote. I always want to draw those in. In fact, you should really, before you do anything, you should really make sure that the horizontal asymptote and the vertical asymptotes, where they cross, is where you want to center your graph. So it makes sense that the very center of our graph is right in the middle there. Alright. So at -1, we're at -0.67. And then at 0, we're at -0.75. And then at 1, we're at -1.33. And then we're heading towards that vertical asymptote again. At 3, we're at 1.2. 4, we're at like a half, kind of. A little above a half. And at 5, we're at like a third. Alright, I think we now know what's going on here. Now, this crosses the x-axis right there, so it does that. But we know it has to go asymptotically towards the the x-axis, so it looks like it kind of comes down, but then starts coming in. And then here, it doesn't cross the x-axis anywhere. I would have found a 0 otherwise, so we're just going to do that, I guess, and then it looks like we're going up. So if we graph it in that window, we should see sort of that. So -8 to 8, scaled it by 1s, and then I went -4 to 4, scaled it by 1, so we should see that now. Yeah, that's looking awesome. I'm pretty happy with that. Okay. Alright, so let's go do one where they're the same degree. It's always a good idea to factor it if you can. This looks like -2, -3 to me. Alright. So nothing cancels, so there's no holes. So let's look at mid behavior and end behavior. End behavior is where the horizontal or oblique asymptote is, and we have a horizontal one because they're the same degree. The only time it's not horizontal is when the degree of the numerator is bigger. So in this case, it's y is the ratio of the leading coefficients. So y equals 1 is where that is. That's going to be really important when we start setting our graph up. Mid behavior, we need vertical asymptotes, holes, zeros, and then the y-end. So vertical asymptotes, x is 2, x is 3. Okay. No holes. 0 is, those are at -1, 0, and 1, 0. And then the y-int is the ratio of the constants, because all these are at 0 and you plug 0 in. So it's -1, 6, which is -0.17 basically. It's like 1.66666, I'm rounding it. There, the analysis done. So now we set up our table. Let's deal with our vertical asymptotes first, 2 and 3. I need something in between them to get the behavior in between the vertical asymptotes, because something's happening in there. If we go back, okay, let's see, 1 and -1 were our zeros. This was our y-int. That's it. So let's go further out a bit to get some end behavior action there. So we want 1, 2, 3, 4, 5 out there. So I'll do 1, 2, 3, 4, 5 out that way. All right. So now we'll go to our calculator to get these. We'll remove this stuff and put that in. X squared minus 1 over x squared minus 5x plus 6. Alright, and then table. Okay, a lot of these numbers are okay. Right, we had -3, -2, -1, 0, 1, 2. Alright, we need 2.5. We don't need that -5, so I'm putting that in there. What else are we missing? 6, 7, and 8. Oops, I erased my -3. Well, we'll get the other stuff here in a minute. I wanted that -3 in there. So let's start at the top. -3 is giving us 0.27, so about a quarter. -2 is giving us 0.15. 1 should give us 0. And yeah, I was right on that one. 1 correct. Vertical asymptote 2.5 is that top number. I get -21. Is that really -21? Yeah. Okay. 4, I'm getting 7.5. 5, I'm getting 4. 6, I'm getting 2.92. So what's 7? 8. 7 is 2.4 and then 2.1. Alright, good enough. Now, to set up our window, we need to be able to center it basically with our, we want to see our end behavior line kind of right in the middle. We also want to see our vertical asymptotes in the middle horizontally. Right? We want to see both of those right in the middle, and we want to see our horizontal asymptote in the middle. So I need to center vertically at 1 and horizontally at 2 and 3. Okay, so if I'm going horizontally, let's see, like 2 and 3. And so that would be 1. And I want to center this at 1. Now, I do get all the way down to negative 21, so that's irritating. So just set this up the way it is. The biggest number I get looks like this. At 4, I got 7.5. So I'll go 8 maxed all the way down to negative 24. Right? If you go by 4s, you'll eventually get there. Okay. So each of these is 2. So the first thing you want to do, okay, x, we still need some more of these. And out to 8, if we can. If we can't, so be it. Oops. There, that window is great. Now, now we plot. Negative 3 and then 1. So before you do anything, put your asymptotes in. Put your horizontal asymptote in. This is the line that it should be approaching. It's in between 1 and 2, 0 and 2 there. The vertical asymptotes were at 2. A lot of people forget to put their horizontal asymptote in, but those are necessary. You have to put them in there. It's easy to remember the vertical asymptotes because you put them in the table. So when you're graphing, if you forget to do everything, if you see VA in there, put the verticals in, and then remember, oh yeah, I need my horizontal as well. Good. Negative 3, 1/4. So 1/4 is about 1/4 of the way up towards that line, so it's barely off the x-axis. And then we're even more barely off it now there, and then we're hitting it here. And at 0, we're at negative 0.17, so we're not down very far there. At 1, we're back at 0. And then at, it's odd. Okay, it's gonna cross the horizontal asymptote. That's okay. At 2.5, we got negative 21. So we're way down there. And then 3 was vertical asymptote. 4 was 7.5. So about right there. Then 4. And that's essentially 3. 2 at 0.4. Remember, that line represents 1. So I think we see what's going on here. We crossed right here. Now it's approaching this horizontal asymptote, and then it's going to cross right there. And then it comes down, goes through there, but then it starts turning around because it crosses again. And it's okay to cross a horizontal asymptote, right? That's okay to do. You can't cross it in your end behavior. It's approaching it in the end, but in the middle behavior, you're allowed to cross a horizontal asymptote. Now, how do we deal with this? Well, it's doing something like this, right? It can't be going the other way, or else there would have been some zeros over here. And then this one is just going to come down like that and approach that asymptote. So that has to be what's happening. So let's see if we are right about that. Negative 3 to 8 by 1s. And then I went negative 24 to 8. And I went by 4s. Hopefully this works out. It's looking pretty good. I'm happy with that. Okay. Cool. So I'm going to stop this video. I'll make a part 2. I suggest you watch part 2 because they're more complicated, and you will see one of these ones where the degree is higher. So the ones where there's an oblique asymptote.